In this video, we are going to be recapping our knowledge on velocity time graphs. We are going to be following the three learning objectives: describing motion of an object, being able to calculate the acceleration of an object using a velocity time graph, and then the higher tier content, which is at the end of this video, is calculating the distance an object has travelled using a velocity time graph. In this video, you will need pen and paper and a calculator for the calculation questions. Please pause this video now and go and get the following items if you do not have them in front of you. We have learned about the difference between speed and velocity. Speed is a scalar quantity and only has a magnitude, whereas velocity is a vector quantity. It is speed in a direction. The speed of an object can change, and this is called acceleration or deceleration. Today, we are going to learn about how to represent the velocity of an object graphically. We're going to start with the first learning objective, being able to describe the motion of an object using a velocity time graph. We know how to work out the speed of an object on a distance time graph, but velocity is different. It is speed in a given direction. We plot velocity on the y-axis and time on the x-axis. Here, this graph shows velocity plotted against time. Firstly, let's have a look at between 0 and 4 seconds. We can see that between 0 and 4 seconds, the velocity increases from 0 to 8 meters per second. This means the velocity is increasing. So the object is accelerating in a positive direction. The object is speeding up. Between 4 and 7 seconds, the velocity does not increase. The velocity stays at 8 meters per second. So the acceleration of the object is 0. From 7 to 10 seconds, velocity is decreasing. The velocity of the object decreases from 8 meters per second to 0 meters per second. So the object is accelerating in a negative direction. This means the object is slowing down or decelerating. Now we can describe the motion of an object. We are going to look at how to calculate the acceleration of an object using a velocity time graph. In a distance time graph, the gradient gave you the speed of an object. However, this is different in velocity time graphs. In velocity time graphs, the gradient of the line gives you the acceleration of the object in meters per second squared. This is because the acceleration can be calculated by dividing the velocity of an object by the time taken. So we are going to use this equation to calculate the acceleration. You divide the change in velocity, which is on the y-axis, by the time taken for that change, which is on the x-axis. And the units for acceleration are meters per second squared. The acceleration showed by the purple line can be calculated as follows. The change in velocity, or the change in y, is 10. The time taken for this change on the x-axis is 2. So the gradient of the line is 5. This means the acceleration of the object is 5 meters per second squared. It is also important to note that the steeper the line, the greater the acceleration of the object. The purple line is steeper than the green line because it represents an object with greater acceleration. Please pause this video now and complete the following 2 questions. Now you have completed questions 1 and 2. Please complete questions 3 and 4 on your paper. The answers to the multiple choice questions were question 1 from 0 to 10 seconds. It is really important to note that the car is moving forwards at all points on this graph. Reminder that acceleration is an increase in speed. So even if there is 0 acceleration, the car is moving at a constant speed, so it is still moving forwards. Question 2, the area under a velocity time graph shows the distance travelled. Calculations of this will be covered in the higher tier section. The gradient of a velocity time graph, question 3, shows acceleration. Question 4, the point in the graph where the object is travelling with the greatest velocity is section D. We are now going to complete the application task part of this lesson. I'm going to explain how to answer the question. The question says, describe the journey taken by a car in section A and B if the velocity time graph of its motion is shown in the graph. We can see that section A is from 0 to 10 seconds. During this time, the car is accelerating at a constant rate in a positive direction. The line is a straight line, so the acceleration is at a constant rate. Because it's accelerating, it is speeding up, and its velocity is increasing from 0 to 15 meters per second. We can read those values off the graph on the y-axis for section A. In section B, from 10 to 15 seconds, the car is decelerating. This means slowing down, and it is decelerating at a constant rate. Its velocity decreases from 15 to 10 meters per second. Again, we can read this off the graph on the y-axis in section B. We are now going to start the we do question. This question says, describe the journey taken by a car in sections C and D if the velocity time graph of its motion is shown in the graph. You have to complete the fill in the gaps for section D and section C. In order to do that, you need to take evidence from the graph by reading off the axes and describing the motion of the car's journey. Please pause the video and complete this question now. The answers to the we do are as follows. In section C, from 15 to 20 seconds, the car is accelerating from 10 to 25 meters per second. In section D, from 20 to 40 seconds, the car is travelling at a constant velocity of 25 meters per second. If for section D you said this acceleration was at a constant rate, then that would be correct. And if for section D you said that there was 0 acceleration, then that would also be correct. You are now going to complete the you do part of this application task. For this question, you need to describe the journey taken by a car if the velocity time graph of its motion is shown in the graph. That means you need to describe the motion of the object from A all the way to D. Please pause the video now and complete this question. The answers to the you do are as follows. You have to describe the entire motion of the journey of the car. From 0 to 10 seconds, the car is accelerating from 0 to 15 meters per second. From 10 to 20 seconds, the car is travelling at a constant speed of 15 meters per second. From 20 to 30 seconds, the car is accelerating from 15 to 25 meters per second. From 30 to 50 seconds, the car is decelerating from 25 meters per second to 0 meters per second, slowing down to a stop. Please pause the video now and self-assess your answer using green pen, making sure you have all the necessary evidence in your answer. We are now going to complete the second application task. This one is about calculating acceleration. In the I do, you need to calculate acceleration from 0 to 10 seconds. In order to do that, you need to work out the gradient of the line. The change in y is 15 take away 0. The change in x is 10 take away 0. Therefore, the gradient of the line is 15 divided by 10, which is 1.5. Therefore, the acceleration of the object is 1.5 meters per second squared. A reminder that this is acceleration, so the units are meters per second squared. You're now going to complete the we do part of the application task. So you have to calculate the acceleration in section B. Remember that to calculate acceleration, you need to calculate the gradient of the line. Please pause the video now and complete the we do. You should have now completed the we do for this question, which was to calculate the acceleration in section B. Notice that the gradient of this line is negative. The change in y is 10 take away 15. The change in x is 15 take away 10. So the gradient can be calculated by minus 5 divided by 5. This gives a gradient of minus 1, which means the acceleration is minus 1 meters per second squared. This is a negative acceleration, so it means the object is decelerating. Please now pause the video and calculate acceleration in both section C and in section D. You should have calculated the following values. The acceleration, so the gradient of the line in section C, is 3 meters per second squared. The acceleration in section D is 0 meters per second squared. The rest of this video is higher content only, so please continue watching this video if you are studying separate science. We are going to be looking at calculating the distance travelled by an object using velocity time graphs. Because distance travelled equals velocity times time, calculating the area under a velocity time graph will give you the distance travelled by the object. I'm going to model how to answer a question, and then there will be some following for you to do as well. So in this question, you're being asked to calculate the distance travelled by the car from 15 to 20 seconds. So we need to calculate everything below the line from 15 to 20 seconds. And I've split this into two sections. Firstly, we're going to calculate the area of the rectangle. This is 5 seconds times 10 meters per second. That is the distance on the x times the y, which is 50. I'm now going to do the second part of the shape. The area of the triangle can be calculated using the equation half base times height. The base of the triangle is 5. The height of the triangle is 15. Times this by half, and you get 37.5. You now need to add both these values together, and you reach the total area of the shape, which is 87.5. This means the distance travelled by the car from 15 to 20 seconds is 87.5 meters. Please pause the video now to complete the we do part. You need to calculate the distance travelled by the car in section A. Remind it that section A is a triangle, so you have the equation to follow. The answer to the we do is the area of the triangle, which is 150 times half, which is 75. So the distance travelled was 75 meters, because we worked out the area of the triangle represented by A. We can see that the base of the triangle is 10 and the height of the triangle is 15. That was how I reached the 150. You then times that by a half, which gets you 75. And the units for distance travelled is again meters. Please now complete the you do section of the application task by calculating the distance travelled by the car in section B and in section D. The challenge question for this video is to calculate the total distance travelled in the whole 40 seconds. Please pause the video now to answer these questions. The answers to the you do were section B, the distance travelled was 62.5 meters. In section D, the distance travelled was 500 meters. And the total distance travelled from A all the way to D was 725 meters.